Now we're starting an interesting section in trig identities, which is using a coordinate plane to help us through some of these problems because we are not given all the trig values that we need. And I'll give you an example. We're told that cosine of phi equals 1/2. We're also told that sine of beta equals radical 13 over 7. But if you remember, how do we find sine of an angle minus another angle? Well, I'm going to write that identity right here. Sine of phi minus beta equals, and think about sine can't change the sine can't change signs. So sine of phi times cosine, sine can't, sine of phi times cosine of beta minus cosine of phi times sine of beta. Well, what's missing here? We don't know sine of phi, we don't know cosine of beta. So we need to find those things out. Sine of phi and cosine of beta. So doing that requires some old skills that we had a while ago. I hope we haven't forgotten them. You're going to need to make a triangle. And you're actually going to need to make two triangles. So hold on. Let me scratch that one. We're going to make two triangles here. One of these triangles is for the angle phi. The other triangle is for the angle beta. And look at what we have here. This information right here, I better color code these things to keep straight what I'm talking about. This information says phi is between 0 and 90 degrees. Well, that's in here somewhere. Okay, so I'm going to say this is my angle phi. I do not need to be accurate about that. That's very important for you to understand. And you're going to see that this triangle is not really that accurate. So if cosine of phi is 1/2, that means adjacent over hypotenuse. There we go, 1/2. So now we use Pythagorean's theorem to figure out what's this missing side right here. Okay, x is not a great name for it. You just say, I don't know, we could call it b. Okay, we say 1 squared plus b squared equals 2 squared. Okay, so go ahead, solve this. Take a moment on your own. You're going to find that that is radical 3 right there. Okay? You might recognize that from the unit circle. Oftentimes you won't. Okay, these are not always going to be pretty numbers. Now let's try the other angle. I'll pick orange for beta right here. Beta is going to be some angle between 0 and pi over 2. Well, we see that's also quadrant 1. It just worked out that way. And I'm drawing a smaller triangle over here just to illustrate the point. These do not need to be accurate triangles. They need to be in the correct quadrant. That's it. So there's my angle beta. And let's see, sine, what is that? That's opposite over adjacent. So that's radical 13 and 7. Okay, so, well, I'll call this side A, and I'm going to say a squared plus radical 13 squared equals 7 squared. Keep working through that. A squared plus 13, radical cancels out, equals 49. And that means a squared equals, little subtraction, 36, which means a equals 6. Okay? With practice, you will start doing these things in your head. I'm going to tell you that most of the time, I've picked the numbers to not work out terribly ugly. Okay? We typically only have a radical on one of the sides of the triangle just because I didn't want ugly numbers any more than you guys. Now, I have two triangles that are fully known at this point. We know all three sides. So I can say things about cosine beta that I couldn't say before. Now I can say cosine beta, hey, that's just 6 over 7. And sine of phi, well, that's just, let's pick a color that's consistent with the graph. Sine of phi is just radical 3 over 2. So now we're going to plug those values in. I'm going to say sine of phi is radical 3 over 2. Cosine of beta, oh, I got to switch back to orange, is 6 over 7. And then we have minus, because sine can't change signs. Cosine of phi, we were given that in the beginning. Okay, that was one of our original values. We just started with 1/2. And sine of beta, we started with that one too. That was radical 13 over 7. Okay, notice the denominators are the same. That's almost always the case in these. I hesitate I hesitate to say always the case, just because I haven't thought ahead on that one. I don't think it would ever be different denominators. That would be very weird. It just works out with the triangles that these are generally going to be the same. But I don't know if I can commit to that. Sometimes there may be scenarios where they're not. Everything that we're doing, though, they will be the same. So here's what we've got. And that's not even how we multiply. There we go. So we get 6 radical 3 minus radical 13 all over 14. And I would just write this as a single equation, or a single rational. It's not even a rational. A single fraction. Let's say it like that. I'm going to write this as a single fraction. 6 times radical 3 minus radical 13 all over 14. That would be my answer. That's the exact value to this question. It is not a decimal approximation. Okay, calculators will tell you a decimal. We're not doing that. We're going for the theory here. I want exact answers.